A handful of tech giants now control the world's most powerful AI hardware, locked behind trillion-dollar walls of capital, exclusive GPU deals, and cities battling to host the next mega data center. Money floods in, resources strain, and ambition spirals higher. But as the fever takes hold, few realize how fragile this gold rush truly is, or how suddenly it could all unravel. What happens when the rush turns to ruin? Money pours in faster than concrete can set. Venture funds wire billions of dollars in weeks, chasing the promise of algorithmic gold. Startup founders sign deals in glass towers, while cranes swing steel beams into place across the world. In Indiana, a single data campus spreads over 1,000 acres, bigger than a small town, built to house row after row of humming GPUs. The numbers are dizzying. $10 billion raised in a single quarter, $50 trillion projected across the industry. 4 names: NVIDIA, Microsoft, Amazon, Google, stamp their logos on the doors of every new server hall, each one fighting to lock down the next shipment of chips before the competition. Cities compete like prospectors, offering tax breaks and water rights behind closed doors. Municipal leaders promise jobs and growth, signing agreements that turn farmland and riverbanks into digital mines. In Mesa, Arizona, and the Dalles, Oregon, city councils meet in secret to outbid their neighbors, eager to attract the next hyperscale giant. But beneath the surface, the game is rigged. The real power sits with the suppliers, the ones who control the picks and shovels of this new age. NVIDIA's exclusive contracts leave smaller players stranded, their dreams priced out by the cost of a single GPU. The few who control the hardware dictate who gets to play. The rest wait in line, watching the market slip further from reach. As the capital torrent accelerates, the world's attention turns to glowing server farms and rising towers. Yet the engines that drive this boom, hidden, relentless, and hungry, remain just out of sight. Every boom needs a supply chain. In the AI gold rush, those supply lines run straight through a handful of boardrooms and city halls. The most coveted resource isn't just talent or capital, it's compute. Graphics processing units, the beating heart of modern AI, are now rationed by secretive allocation memos and long-term contracts. Microsoft, Amazon, and Google sign multi-year deals with chip makers, locking in priority access while smaller firms scramble for leftovers. Cities play their part, too. Mayors and economic development officers draft incentive packages in the dead of night, offering tax abatements, discounted electricity, and millions of gallons of water per day just to lure the next hyperscale build. In Mesa, Arizona, city officials agreed to supply enough water for a data campus to cool thousands of chips, even as drought warnings flashed across the state. The Dalles, Oregon, promised infrastructure upgrades and tax relief to attract cloud giants, trading farmland for server racks. The winners of these negotiations don't just get jobs, they get a seat at the table of the new digital economy. But the price is steep. Exclusive accelerator deals mean that only the biggest players can guarantee delivery of the latest hardware. Municipalities eager for growth accept terms that tie local resources to the fortunes of distant corporations. Behind the glow of server farms and the promise of progress, the real story is written in contracts and water rights, where access, not innovation, decides who survives the rush. Electricity demand surges past projections. In Northern Virginia, data centers now draw more power than entire cities. Regional usage has jumped by double digits in just 2 years. Utility managers scramble to keep the lights on, signing emergency contracts for diesel generators and peaker plants. In Texas, grid operators warn of rolling blackouts as server farms outbid hospitals for the last kilowatts during heat waves. The strain is relentless, and every new hyperscale campus brings a fresh spike in demand. Water disappears just as quickly. A single Google data center can drain 450,000 gallons a day for cooling, enough to supply thousands of homes. In drought-prone Arizona, city wells run low while hyperscalers pump millions of gallons for evaporative towers. Farmers and residents face restrictions, but the servers never pause. The financial burn rate is just as punishing. Startups once valued in the billions collapse under the weight of their own cloud bills. In early 2025, a well-funded AI firm is forced into a fire sale, its runway wiped out by runaway compute costs. Board memos leak, revealing panic as investors realize the math no longer works. Profits hide in the server room, drowned by power bills, depreciation, and unrealistic goals. Even the models themselves begin to falter. Internal memos from major labs warn of a data quality crisis. Models trained on synthetic data start to loop, learning from their own outputs until accuracy drops and truth blurs into a copy of a copy. Quality collapses into repetition. The golden sphere. At the heart of the rush begins to crack, lines spreading across the surface as the system strains under its own weight. Inside the core of these models, something begins to unravel. Each new generation is trained not on fresh human insight, but on the outputs of its own kind, synthetic data feeding synthetic minds. The process repeats in silence, layer after layer, until knowledge starts to blur at the edges. In controlled studies, researchers found that after just a handful of recursive cycles, diversity in output collapsed by half. Factual accuracy dropped, errors multiplied, and the models began echoing themselves, repeating patterns, amplifying mistakes, losing touch with the world outside the data center walls. Internal memos from leading labs describe a growing sense of unease. Engineers watch as their creations drift, learning from a copy of a copy, each pass stripping away a little more detail, a little more truth. Benchmarks show a steady decline, a 30% to 60% reduction in variety, a measurable rise in hallucinated facts, and a narrowing of perspective that no patch or parameter can fix. The golden sphere at the heart of the system fractures, lines crawling across its surface as the feedback loop tightens. Industry guidelines now warn against recursive self-training, but the hunger for scale pushes boundaries faster than best practices can keep up. Synthetic data, once a shortcut to progress, becomes a trap. Models drifting into abstraction, their outputs polished but hollow. In the rush to build bigger and faster, the foundation of knowledge itself begins to rot. What was once a tool for understanding the world becomes a mirror, reflecting only its own fading light. In the hush of early morning, the racks stand cold. Miles of cable and steel, once alive with energy, now sit in silence. Cooling towers idle, their thirst for water momentarily paused. Policy binders gather dust in city offices, thick with proposals, thin on enforcement. Congressional hearings echo with empty chairs, while unread reports stack up behind closed doors. Regulation, always a step behind, lags the pace of expansion. Across the country, local councils debate guidelines that never materialize, leaving communities exposed. The infrastructure remains, vast, expensive, and unaccountable, waiting for clarity that never comes. What is left behind is not just hardware, but a vacuum where oversight should be. The cost is measured not only in power and water, but in the absence of clear responsibility. In this silence, the true price of unchecked ambition becomes impossible to ignore. In a quiet workshop, one engineer powers up a recycled server. The machine hums, but the load is light. Instead of chasing ever larger models, she fine-tunes a small neural network with LoRa, low-rank adaptation, using a fraction of the energy once needed. Her code runs on hardware salvaged from a shuttered crypto mine, drawing less power than a single air conditioner. Across the globe, a growing community shares open-source adapters and distilled models, proving that useful intelligence does not demand endless scale. In finance, healthcare, and science, these efficient systems handle routine work with accuracy and transparency. The movement is small, but its impact is real, cutting costs, saving water, and extending the life of old machines. Here, progress means restraint. The promise is not in infinite growth, but in careful stewardship. One model, one server, one mindful choice at a time. Today, as AI data centers draw more power than some nations, and fresh models feed on their own synthetic echoes, the cost of chasing limitless intelligence keeps rising. Progress without restraint isn't innovation, it's risk, multiplied. The next breakthrough may not be code, but the discipline to pause,